Hello and welcome to another video of Matuklasan. Language is the reason why people can communicate and express themselves. This system is usually spoken, signed, or written in symbols. There are about 6,500 languages in the world. In the Philippines alone, there are about 120 to 187 languages spoken, depending on the method of classification. Language is like the internet that connects people in the world, and there is no doubt that language is an indispensable tool. Even the brilliant writers of some of the famous movies in Hollywood invented the language for a more realistic storyline. And math is not a different matter. Mathematics has its own language, which makes it easy to express the kinds of thoughts that mathematicians like to express. It's also part of our everyday life. For instance, we use decimal digits in the morning for us to determine the time, whenever we're at a grocery, or when we ask for someone's cell phone number. In fact, it would be difficult for us to imagine the world without numbers. Why? Because mathematical language is precise. A little manipulation of symbols may mean a different thing, like 1 is different from 11. This is one of the reasons why math is considered an exact science. There are many symbols in mathematics. To understand their meaning, there are two things that might help us. First is knowing the context. Numbers have many uses, so it's very important to know when to use them. 8, 0, and 7 will be read as 807 in the context of time, and 807 if pertaining to a number. Another is the different uses of degrees in angle measures, temperature, and bearing. We should also know mathematical conventions. A mathematical convention is a fact, name, notation, or usage which is generally agreed upon by many mathematicians. Example is the PEMDAS rule, which we use for arithmetic operations, wherein multiplication and division are done next in order as you read them from left to right. Majority of the mathematical names and symbols that we are using are conventional because they have been used by majority of math learners for many years. The usual math symbols are operators, variables, and Greek letters. Now, let us look at some symbols commonly associated with mathematical operations. The two most famous operators are the plus and the minus. The plus and minus signs are mathematical symbols used to represent the notions of positive and negative, as well as the operations of addition and subtraction. Again, to understand these symbols, we need a context, because aside from their typical use in math formulas, they are also used in communication devices, chemical formulas, blood types, and even music. There are many other operators in math like multiply and divide, for which they are used extensively in many equations and formulas. Ginamit pa nga ni Ed Sheeran sa mga album covers niya, di ba? Variables are another form of mathematical symbol. These are used when quantities take different values. These symbols are very important because some measures and characteristics may vary, such as the speed of the car, prices of commodities, number of births per year, height of NBA players, etc. Greek letters are also used in many calculations. For example, the Greek letter pi, written as shown, is used to represent the number 3.14159. This number continues forever without repeating. We often use alpha, beta, and theta to represent angles. The Greek capital letter sigma is frequently used to represent the addition of several numbers. Aside from being precise, mathematical language is also concise, or being able to say or write things briefly. we can always convert mathematical sentences into equations or expressions. For instance, instead of writing the sum of 6 and a number, we can write the expression 6 plus x, wherein the number, which is the unknown, is represented by a variable. Instead of writing a number increased by 7, we can write x plus 7. And 10 times a number can be written as 10.n or 10 times n. Here are some of the other English translations of the four operators. Being able to convert sentences into mathematical expressions correctly is one of the skills that we need to learn if we want to solve particular problems. Mathematical language is a powerful tool because it can express complex thoughts by just using equations and formula. For instance, work is an activity that involves mental or physical effort done in order to achieve a purpose or a result. Now, what if we want to measure work so that it could be useful in different industries? This is possible when you use the formula work equals force times distance. And this is how we use math in interpreting natural occurrences and other complex phenomena. The brightest minds in history have used mathematics to lay the foundation for how we measure and understand our universe. Time and time again, we have proved that it only takes one simple formula to alter the course of humanity. Here are 10 equations that did just that. There are many unexplained questions about the existence and movements of the heavenly bodies before Newton discovered the law of universal gravitation. Newton used a mathematical formula to accurately predict the motions of any objects relative to the gravity. The theories of Newton laid the foundation of the modern physics that we still use today. However, Albert Einstein thought of an equation that could explain the universe as a whole, and his famous formula, E_mc squared, radically altered the course of physics and deepened our knowledge on the universe's past, present, and future. Imagine, aside from the creation of the atomic bomb, which literally ended the World War II, it even paved the way in the possibility of a time machine. The Pythagorean theorem is one of the oldest equations in the list, but the relationship it shows among the sides of a right triangle is widely used today in surveying, astronomy, engineering, and many more. Maxwell's set of equations for electromagnetism have been called the second great unification in physics, after the first one realized by Isaac Newton. Well, thanks to him, we know how to generate electricity today. Speaking of which, Rudolf Clausius' second law of thermodynamics led to the development of technologies like internal combustion engines, which we use in our cars, cryogenics, and electricity generation. The equation that is shown on the left is the definition of the derivative in differential calculus, one of the calculus' two major branches. It might have been difficult or impossible for Newton to explain and develop his laws of motion and gravitation if not because of calculus. Next on the list is the Schrödinger's equation. This equation describes how the quantum state of a quantum system changes with time. It governs the behavior of atoms and subatomic particles in quantum mechanics. Schrödinger's equation paved the way for nuclear power, microchips, electron microscopes, and quantum computing. Yeah, we have smartphones and powerful computers today because of this equation. And since pinag-uusapan na rin ng computer, information theory is a branch of mathematics that studies the coding of information in the form of sequences and symbols, and the speed at which the information can be transmitted. The formula on the left is instrumental in the development of internet and mobile phones today. At kung may lolo ang computer, eto na yung calculator. And logarithms were introduced by John Napier as a way to simplify calculations. Logarithms were adopted by early navigators, scientists, and engineers. Pero syempre ngayon, mas madali na yan. Pero kung di dahil dito, wala tayong magandang foundation para sa programming sa computer. This last equation on the list may sound chaotic, but chaos theory is a branch of mathematics that studies complex systems whose behavior is extremely sensitive to slight changes in conditions. In essence, it shows how small alterations can lead to consequences of much greater scale. Chaos theory has applications just about everywhere: meteorology, sociology, physics, computer science, engineering, economics, biology, and philosophy. Learning math is like meeting someone with a different language. It might seem difficult to understand each other, but there are many ways to communicate, and we just have to find a way. Anyway, if you want to know the meaning of this binary code, you just have to go to Google and find a binary to text translator.